Good afternoon. I think we'll just get started now. We're almost done with sequences and series. Today we look at the last exercise in the chapter, and once we're done with that, we'll revert back to chapter 4.7, finish that off. Then once we're done with 4.7, then we're basically done with the course outline. So the only thing left after that is the last test, which I'm sure you know the date is on e-learning, so you should get ready for that one. Okay, so let's look at exercise 5.3.4. Okay, so here we're given a sum in sigma notation. Let's say I goes from 1 to 4, and this is I to the power of 3. Now I to the power of 3 is not geometric, it is not arithmetic, so we cannot use the formula for Sn. So here, because we have only a few terms, we can easily calculate this. So I will start at 1, then I goes to 2, 3, and then 4. So this sum is just equal to 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. So this one is fairly simple to do. You work it out on your calculator. 1 plus 8 plus 27 plus 64. This is equal to 100. Then number 2, this is the sum I equal to 2, 7 of I. Okay, now this one here, this is an arithmetic progression. Now you'll be able to tell whether it's arithmetic or geometric in that arithmetic, your formula that you have over here is the formula of a straight line. It's linear. And geometric, you will have a number to the power of n minus 1, for example, or I minus 1, I plus something. Okay, so that's how you tell whether it's geometric or arithmetic. Now here we're just adding the numbers from 2 to 7 because I goes from 2 to 7. We can use the formula for an arithmetic progression. We can see here our A, this is when I is equal to 2, this is equal to 2. And our D, I say it is always the coefficient of the variable that you have here. Here my coefficient is 1, so D is equal to 1. And then how many terms do I have? I'm counting from 2 to 7. If I started counting from 1 to 7, I would have 7 terms.
Miss.
Yeah.
Which coefficient we must take as D?
The one in front of the variable. Here my variable is I. The coefficient of I is 1. Yeah.
Okay.
Yeah.
If it was 2I, then the D is 2.
Yes. Or you can do it the
Okay.
other way that I showed you, where you work out the first term and the second term and then the difference. So here, let me show you. Here the first term is 2. The second term, U2 will be 3. So A is 2. Then I will say D is equal to 3 minus 2, which is 1. So you can work it out like that as well. But you will always see that whatever coefficient you have here, that is your D. Yeah?
The third term is D, which are the second. I want to say the second term is 3.
Yes.
Oh,
Yeah.
it's just because I cannot see where you are pointing. Your arrow is not moving.
It's here. This is my starting point. This is my ending point. So I'll substitute I from there in there. So I start with 2. The first term is when I is 2. The second one is when I is 3. Then I is 4. And then you end when I is 7. Okay.
Okay.
So do it either this way, where you say d is just the coefficient of I, or work out the first term and the second term, and then you know how to say d is the second term minus the first term. The answers will always be the same. Okay, so now
Okay,
that
miss.
n will be 6, so the reason n is 6 is because I said if I'm counting from 1 to 7, I have 7 terms here. Then if I'm counting from 2 to 7, it means 1 is no longer included. So that means I must have 6 terms now. So that's why n is 6. So we're looking for the sum of the first 6 numbers in this arithmetic progression. So this is S6. This is equal to n, which is 6 divided by 2. Then 2 times a, which is 2 times 2, plus n, which is 6 minus 1, multiplied by d, which is 1. Okay, then this you can just work out on your calculator. This is 3, 4 plus 5. 4 plus 5 is 9. 9 times 3, this is 27. Okay, now because these were just a few terms, there are only 6 of them, you could also have worked it out just by writing them. So you say 2 plus 3 plus 4 plus 5 plus 6 plus 7. You will still get the same answer. And that I can do because I have only a few terms. When I have 20 terms, 30 terms, 1,000 terms, I cannot list all of them. It will take me quite a long time to do that. Then number 3, we have a sum, go I equal to 2 up to 1,000, and again we're adding I. So here I said if you look at what you have, if it is linear, then it is an arithmetic progression. And with an arithmetic progression, you know how to work out the sum of the first n terms. Now here n, this is going to be 1,000 minus 1, which is 999. Okay, so again, if I was starting counting from 1 to 1,000, I will have 1,000 numbers, but then 1 is not included because my starting point is 2, then it's 999 terms. Then A is just equal to 2 because my starting point is when I is 2 and I is the first term. And then D, we say D is the coefficient of I. Here the coefficient of I is 1. Okay, so D is 1. Then I write down my formula. The sum of the first 999 terms. This is given by 999 divided by 2. Say 2 times the first term plus n minus 1, so it's 999 minus 1, and then you multiply this by the common difference. So this again, you just work it out on your calculator. This is 500,499. Okay, is that fine?
No, miss.
Why not?
For me, I cannot get how did you get the nth term is 999.
I mean, you don't see how it's 999 terms, or
Yes, miss.
it's because I said if I'm counting from 1 and I'm going all the way up until 1,000, how many terms do I have?
Or the number that always up the sum to infinity sign is always the last term.
Yes, that is the That is the term that you stop at. So the number up here,
Okay.
this is your end point. This is your starting point.
Okay.
All right.
Okay.
Mm-hmm. Okay. Then next one, number 4. Here we have the sum I starts at 1, and then this time we are going to infinity, so 0.2 I. So this one is geometric. Okay, the reason I can tell it's geometric is because your variable is now the exponent. So when the variable is the exponent, it means you have a geometric series. And we said that the sum to infinity may or may not exist, so you must always check to find out whether it exists or not. Now, the way to check whether it exists or not is by taking the absolute value of r. If your absolute value of r is less than 1, then the sum to infinity exists. Okay, if your absolute value of r is greater than 1, then the sum to infinity does not exist. So here, a, your first term, this is when I is equal to 1. So this is just 0.2 to the power of 1, which is 0.2. Now r, just like we were doing in the arithmetic progression, this is the base of whatever exponent you have over there. So this is 0.2. Okay, and then we test to see if the sum to infinity exists. So I'll take the absolute value of my r, which is absolute value of 0.2. This is just 0.2. Now 0.2 is less than 1, therefore the sum to infinity exists. Now because this sum to infinity exists, I can work it out. The sum to infinity, the formula is a over 1 minus r. Now a, we say this is 0.2, 1 minus 0.2. This is just equal to 1 over 4. And number 5, here we have the sum. M is 1, so that means my starting point is at 1, and then I'm adding to infinity, and this time I have 2 to the power of m. So again, this is geometric, okay, because the variable is the exponent. So that's what tells me whether it is arithmetic or geometric. Now here, I always need to test, does this sum to infinity exist or not? So my a, this is 2 to the power of 1 because that is my starting point. I substitute the starting point over there, and that is why I say a is equal to 2. Then r is just the base of that expression, and the base here is 2. So I need to test, does this sum to infinity exist? So I take my absolute value of r, absolute value of 2, this is equal to 2. 2 is not less than 1, therefore the sum to infinity does not exist. Okay, so that's how you'd write it. The sum does not exist. And then number 6, the sum I equal to 2, 5, and
Miss,
I. Yeah.
that means when the sum to infinity does not exist, we must not calculate further.
Yes, because it doesn't exist, so you cannot even calculate it.
Like that, you can get your all marks. just
Yes,
indicating that does not exist.
yes, but you will lose marks if you calculate further, because you're telling me it doesn't exist and then you are giving me an answer. So you will lose marks if you calculate, because the formula will not stop you. You can use the formula whether it exists or not, but let's look at that. Let's see. So here, you know, the formula is A over 1 minus R. I can still use the formula here, and my A, we say it is 2, and I have 1 minus 2. This gives me negative 2, isn't it? But if you look
Yes.
at what you have here, 2 to the power of m, the numbers in this series are 2, 4, 8, 16, and so on. So is it possible to add those numbers like that continuously and then your final answer is negative 2? All of them are positive, all of them are bigger than negative 2, but you're saying that the sum to infinity is negative 2, which doesn't make sense. So you see the formula, I don't get a math error. It's a number, it's defined, but it does not exist. So you should not calculate it. You just stop, does not exist.
Okay, miss.
Right. Then number 6, this one is arithmetic, because what I have over here, this is linear. We say that the first term A, I just substitute the starting point where I have I, so this is 2 minus 1, which is equal to 1. And then my D, this is the coefficient of I, which is equal to 1. And then N is how many terms do I have? If I start at 2 and then I end at 5, I have 2, 3, 4, and 5. Okay, so that is 4 terms. Okay, so here if I was counting from 1 to 5, I would have 5 terms, but then I start 2 to 5, it means 1 is left out, so now I have 4 terms. Okay, so now I have everything I need. I have A, D, and N. I can work out the sum of the first 4 terms. This is N over 2, so this is 4 over 2. Then 2 times A, which is 2 times 1, plus N minus 1, which is 4 minus 1, multiplied by D, which is 1. Then again, this you work it out on your calculator, and you should get 10, if I'm correct. Okay, then the next one, number 7. We have the sum k equal to 1 to infinity 1 over 3 to the power of k. Now this 1 over 3 to the power of k, you can look at it like this. So I'll rewrite it. K is equal to 1 to infinity of 1 over 3 to the power of k. So these two, they are equal. Okay, so here I can see that this is geometric because my exponent is the variable that is increasing. It's the sum to infinity. So first of all, I need to check whether this sum exists or not. So my A, this is 1 over 3, and then the starting point of k, this is 1, so this is just 1 over 3. Then R is whatever number has the exponent k, so R is 1 over 3. And then to check whether it exists or not, I take absolute value of R, which is absolute value of 1 over 3, which is 1 over 3. 1 over 3 is less than 1, therefore this sum exists. Now because it exists, I can work it out. If you say it does not exist, then you stop there, you don't work it out. So the sum to infinity, you say the formula is a, which is 1 over 3, and then you divide this by 1 minus r, which is also equal to 1 over 3. This you do on your calculator, and you should get a half. In number 8, we are told to write in sigma notation, so it's the other way around. We're given a sum, so with A, we are given 3 plus 1 plus 1 over 3 plus, and then some terms there, and then the last one where we stop is 1 over 81. So we're told to rewrite this in sigma notation. Now to write in sigma notation, we need the sigma symbol. Then you need to tell me what is the starting point, what is the end point, and then you need to put the formula for the nth term. That's it. So here you need to decide, is this an arithmetic or is it a geometric progression or series? This one is obviously geometric, because if I divide these two, 1 divided by 3, I get 1 over 3. 1 over 3 divided by 1, I get 1 over 3. So I can see that r is equal to 3. R is equal to 1 over 3. Then the starting point A, you can see it is 3. It's written there. Now I need to find the formula for the nth term. So un, this is equal to A, which is 3, multiplied by r, which is 1 over 3, to the power of n minus 1. Okay, so here the letter that you use, whether you want to use N, T, K, L, it doesn't matter, as long as you show that you have a variable there. Then you cannot simplify it any further, so you just leave it as it is. Now your starting point is going to be 1, and then your end point is how many terms you have over there. So you need to work out n if the nth term is 1 over 81. So we want to find n. So we know that the nth term where we stop is 1 over 81. That's given to us in the series. And we know the formula for the nth term is 3 times 1 over 3 to the power of n minus 1. So I'll take these 2 and then solve for n. So let me write it as 3, 1 over 3 to the power of n minus 1. This is equal to 1 over 81. Then I divide by 3 on both sides. I have 1 over 3 to the power of n minus 1. This is equal to 1 over 243. Okay, then you know how to solve this. You can take logs on both sides, or you can rewrite the right hand side as 1 over 3 to the power of 4. So I have 1 over 3 n minus 1. This is equal to 1 over 3 to the power of 5. Now the bases are the same. Both of them are 1 over 3. So it means that the exponents must also be equal. So this means that n is equal to 6. Okay, so now I have my starting point is 1. My end point is 6. The formula for the nth term, I've worked it out, so I just write it. So sum, here I say n is equal to 1. My end point is 6. Then I have 3, 1 over 3 to the power of n minus 1. And that's it. Is that fine?
This is a bit complicated.
Is it? Because I'm just substituting. I know what should go here. This is my starting point. What should go there is my end point, and what goes over here is the formula for the nth term. That's it.
Okay.
Let's do the last one, 8b. So with 8b, we are given an arithmetic progression. It's 26 plus 23 plus 20 plus 17 plus 14 plus 11 plus 8 plus 5. Here all the terms are listed. So when you're looking for n, you'll just count how many terms you have. So remember again the way we write the sigma notation. This is our start value, which is always going to be 1. And here this is our end point, the number of terms that you have. Here, like I said, the terms are all listed, so I'll just count how many I have. And then here, this is the formula for the nth term. So this one, you can check the sequence or series that we give you will always be arithmetic or geometric. Okay, maybe some other simple ones that you should be able to tell where it's squared, all the terms are squared, you should be able to see that what the pattern is, but it won't be any other complicated formula. So here you can check whether this is geometric. You say 23 divided by 26, you get to 0.884. Then you say 20 divided by 23, you get 0.86. So already the ratio is not the same between the second and first and the third and second. So automatically it is not geometric. But now when I look at the difference, 23 minus 26 is negative 3. 20 minus 23 is negative 3. 17 minus 20 is negative 3. So this one is arithmetic. So what I need to do is put my start, my end point, and the formula for the nth term. So for an arithmetic progression, the formula for the nth term, this is a plus 1 minus n minus 1 times d. Now a here is the starting point, which is 26. And then I put n minus 1. And then d is 23 minus 26, which is negative 3. Then you simplify this as far as possible. This is 26. The negative 3 multiplies inside, so you have negative 3n plus 3. So this is equal to 26 plus 3, which is 29 minus 3n. Okay, so now I have my formula for the nth term, and that is what I'm going to put over there. Then we say the starting point is always 1, and then the end point is how many terms you have. So we count them. We have 1, 2, 3, 4, 5, 6, 7, 8. So my end point is going to be 8. So this is how I'll write it. Sum n, which whatever variable you put over there, that's the same one you put over there. So n starts at 1 and we end at 8 because there are 8 terms when I counted them. And then I put the formula here, 29 minus 3n. And that's how you would write it. Do you have any questions? Or is it fine?
Miss,
Mm-hmm.
why do we find sometimes where you put n is equal to 1?
Mm-hmm.
You might sometimes find any any number, any letter, or let's say n is equal to 2. Sometimes we might start at the second term or what, because I
Okay.
think that one represent the first term most.
Yes. When n is not 1, that means you are finding the sum of the terms, let's say from the second one up until the 10th one, for example. Now when
Oh,
that is when it's written for you. All the ones when we had k is equal to 2, k is equal to 5, those ones they were given to you like that. But you see, this time it's the other way around. When it's you who is writing it, let me see. When you are given this and you want to write the sum,
yeah.
you will always start at 1. I can give you a question where I'm
Oh,
not interested in the first n terms. I could say start from 23 to 5 over there. So you can see I start when k is equal to 2. But when you are rewriting it, because you start at your first term, here when you are writing it, you'll say 23 is your first term. I don't know if that makes sense.
okay, miss. Okay, but like when we are calculating the number of terms, like,
Mm-hmm.
mm, can you please scroll to the solution we got now?
This one.
Yeah,
Mm-hmm.
like when we are calculating the number of terms from the
Mm-hmm.
start point to the end point,
Mm-hmm.
here we are saying there are 8 terms,
Yes.
because we started at 1.
No, because I counted them. They're here. All the terms were listed. So this is what I was given. I just counted them. I said there's
Oh,
1, 2, 3, 4, 5, 6, 7, 8.
okay,
Yeah. With the
okay,
previous
okay,
one,
ma'am.
the terms were not all listed. There were some in the middle. So let me just scroll. You can see over here, this tells me that there are some terms in the middle. So I cannot just count and say it's 4 terms, because it's not. There are some terms here which are not listed, but I also need to count them. So
Okay,
with this
miss.
one, yeah, okay. Right. So with that, we are done with sequences and series. Now we will go backwards a little bit and look at graphical um, presentation of functions. So this is unit 4.7. Okay, so we have y is equal to 3x plus 1. This is the equation of a straight line. So what we need to know about this is the independent variable, and this one here is dependent. So just like in English, when we talk about independent and dependent, here it means that the value of y depends on what x is. So x can be anything, but y depends on what x is. So here we also have terms like the domain. So I mentioned this a little bit when we were talking about logarithmic graphs. Now the domain, these are just the set of values from which x is chosen. Okay, so these are your x values that you are allowed to input into the function. That is your domain. And then the range is just your output. This is the set of output y values. Okay, so domain, this is your input, what you're allowed to put into the function, and then the range is your output. Okay, now we also have the term an ordered pair. An ordered pair looks like this. This is x and y. So in an example of an ordered pair is this one here, 2, 3. Now it is called an ordered pair. Firstly, pair because it's two terms, and then ordered because the way you put them in matters. So you'll notice that 2, 3 is not the same as 3, 2, even though in both of them you have a 2 and a 3, but because in the first one 2 comes first and then y, it is not the same as when 3 comes first and then y. So this represents the x coordinate and that represents the y coordinate. Okay, so it's ordered, that means the order matters, and pair, it is two of them. Now these ordered pairs, we plot them on the x and y axis. So you have your x-axis, you have your y-axis. Now this is called the first quadrant. So quadrant like 4, so it's like you have your paper and then you divide it into 4 parts. So each of those is called a quadrant. Then this is your second quadrant. This is your third quadrant. And this is your fourth quadrant. So your points, you can plot them here. For example, 2, 3, that is where it is. It is in the first quadrant. And then -1, 2, that is in the second quadrant. We have -3, -4, that is in the fourth quadrant. And then let's say 6, -2, that is in the fourth quadrant. Okay, then the very first graph we look at is the straight line. Now in standard form, the straight line is written as y is equal to mx plus c. So this m over here, this is your gradient. And your c here, this is your y-intercept. Okay, so at the y-intercept, we know that x is equal to 0. So if I substitute x is equal to 0, you will only be left with y is equal to c. So that is called your y-intercept. Now when you're drawing a line, there are 3 ways that you can do it. You can use a table. So that means you have your x and y points. So you have x, let's say put 1, 2, 3, 4, and then you work out the values of y depending on your equation. Let's say we have y is equal to 2x plus 1. So I will say 1, substitute it there. So 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. 2 times 3 plus 1, this is 7. And then 2 times 4 plus 1 is 9. Then you go to your graph and then you plot all these points and then connect them. So you have 1, 3, it's here, 2, 5, maybe it's somewhere there, 3, 7 there, and then you connect them with a ruler, and then that is your line. Then you label it y is equal to 2x plus 1, but I'm sure you know how to do that. Then the second way of drawing a straight line is you take any 2 points and connect them. Any 2 points on the line, and then you connect them. Okay, so if you know 2 points that lie on the line, so let's say I have my x-axis and my y-axis over there, and then I give you the coordinates of 2 points. Let's say here I have -2, 3, and then somewhere here I have 5, 6, you know that those are 2 points that lie on the line. You just plot them, and then you take a ruler and you join the 2 points with your line, and then you write y is equal to mx plus c, whatever your equation of the line is. Okay, so that's the first, that's the second way. Then the third way of drawing a line is using the gradient intercept method. So here, let's look at an example. Let's say I have this 3y plus 3 is equal to 6x. I will write this in standard form. That means it's in the form y is equal to mx plus c, or you make y the subject of the formula. So you have 3y, this is equal to 6x minus 3. Then you divide by 3 on both sides. You have y is equal to 6 divided by 3. This is 2x. And then negative 3 divided by 3. This is 1. So first you put it in standard form. Then you say my gradient, this is the coefficient of x, this is 2, and c is that value over here, which is minus 1. So what you do is you plot the point C. This is my x-axis, this is my y-axis. So at C, x is equal to 0 and y is equal to negative 1. So that will be somewhere here, negative 1. Then you use the gradient to shift this point over here. Now your gradient, you write it as a fraction, so you can write it as 2 over 1. So remember your numerator, this is delta y, and your denominator, this is delta x. So what you do is you move 2 units up because delta y is positive 2. So what you do is at negative 1, you move 1 unit, and then another unit, you end up at 2. And then delta x is positive 1, that means you move 1 unit to the right. So you can see I've moved 2 units because delta y is positive 2. And then I move 1 unit to the right because delta x is equal to 1. Then this point here where I end up at, I will take my ruler and connect it with my original point. So connect them like that. And this
What's going on, Nan?
Hello? Can you hear me?
I miss Mr. Wapian.
Can you hear me? Hello?
Yes, miss. Now we can
Yeah,
hear you.
Okay.
I can hear you,
Okay.
Miss, now.
Sorry, I don't know what happened. Okay. Let's continue. Share. Okay. So can you see my screen?
Now,
Yeah.
Can you see it?
yes,
Yes,
we
miss,
can
you can
see.
see.
Okay. So, like I was saying, you pick your starting point. Then, depending on your gradient, the numerator is delta y, and then your denominator is the change in x. So here, if it's positive, that means you must go up the number of units you have in the numerator, and if it is negative, then you'll go down. Then same thing with delta x. If it is positive, you go to the right. If it is negative, you go to the left. And then you just connect those 2 points, and then you label your line. Y is equal to 2x minus 1. Okay, look at another example. We are told to draw a line whose gradient is 2 over 3, and then it passes through 1 comma 2. So here we'll use the gradient point method. So what you do is you draw your x and y axis. So this is my x axis, that is my y axis. So we're told it passes through the point 1 comma 2. So say 1. Okay, so this is the point 1 comma 2. Then what I will do is I will shift this point. Now remember my numerator, this is delta y. So that means I will go up 2 units. So I go 1, 2. So this number here will be 4. And then the denominator, this is my delta x. So I will go 3 units to the right. So I have 1, 2, 3. So I will end up at 4. So that's here. So first you go 1, 2, 1, 2, 3 there. So this is the point. Then you take your ruler and then you connect them like that. So on your graph paper, you'll be able to see clearly that this point here is negative 2 and that point there is 1. So you can label your graph. So here you can also work out the equation. Y is equal to 2 over 3 because that is your gradient which was given, x, and then the intercept, you read it from the graph, this is plus 1. Okay, so that's it. So using the gradient to draw a line is not difficult. Just remember the numerator tells you how many units up or down to move, and then your denominator tells you how many units left or right to move. So get another point from the point that you started with, and then you just take a ruler and connect the 2 points. Then,
Miss,
yeah,
like for the denominator, because we cannot have a denominator as a negative, we always move to the right side when you are looking for the x units or what.
you can have a denominator that is negative. If you have a gradient,
That's why
let's
I'm
say,
asking now, Miss.
yeah, you can have a denominator that is negative. So if, let's say, for example,
Yeah,
I have this, we have a point 1 comma 1, and then I tell you that the gradient is negative a half. Negative a half, you can also look at it as 1 over negative 2. Those are the same. So if you first look at it that way, you can say I will move 1 unit up. So I will move 1 unit up and then 2 units to the left. I will end up there. Then you take your ruler and you connect them. Then you could also look at it in the other way. You say it's this one, so I'll move 1 unit down and then 2 units to the right. You'll end up here, and if you connect them, you see it's still the same line.
Okay, miss.
Yeah, so it doesn't
What I
matter
was
whether you
minding is just what I was minding is that we cannot have a denominator as a negative most.
why not?
Or we can have.
Yes, because the denominator is delta x. The difference between the x values can be negative, can it not?
o-
Because
Okay,
here, the first one I've written, the denominator is negative. So your change in x can be negative. I'm sure you've
okay, miss.
done calculations like that where you saw that delta x is negative, even though delta y is positive. But anyway, your gradient, it's not even that which one is negative or positive. Even this negative a half, I could write it as negative 2 over 4. Then I move 2 units down and then 4 units to the right. I will still get exactly the same line, except maybe my points are further away. Okay, so if I tell you the
Oh,
gradient is 1, you can say this is 5 over 5. You move 5 units up, 5 units to the right, it'll still be on exactly the same line, except that the points are now further away. Okay,
okay, miss.
yeah. Okay, so we can also use this graphing method to solve simultaneous equations. So for example, if you are given this 2y minus 4x is equal to 4 and 8y minus 1 is equal to 2x minus 13. So I tell you to solve these by graphing. So what you'll first do is write each of them in standard form. So when you do that, this is your first one, this is your second one. The first one, when I write it in standard form, I will have y is equal to 2x plus 2. So this negative 4x, take it to the other side, and then you divide by the 2 throughout. This is what you get. Then equation number 2, you will have y is equal to 1 over 4x minus 3 over 2. So what did I do? I add 1 on both sides. You get negative 12, and then you divide by 8. So you have 2 divided by 8, which is 1 over 4, and then 12 divided by 8, which is negative 3 over 2. So now that I have them in this form, I know what the intercepts are. This is your C, and that is your C. I know what the gradients are. I can quickly sketch both of them, and then I look for the point of intersection. So if I draw them, so in your book it'll be easier to draw. For the first one, the C value is 2, so that's 2, 0, so that's somewhere here. This is 2. Then my gradient M is equal to 2, so this I can write it as 2 over 1. So I will move 2 units up and then 1 unit to the right. So I go 2 units up and then 1 unit over to the right. Then I take my ruler, I connect the 2 points, then you label your line. Y is equal to 2x plus 2. Then because you'll be doing this on a graph, you'll be able to read what this value is. Here I got negative 1. So on your graph, even with quad paper, it's easy to tell what the coordinate of the x-intercept are. Then I do the same thing with the second line. My value of c is negative 3 over 2. So negative 3 over 2 is negative 1.5. So that's somewhere here. So this is negative 3 over 2. And then the gradient is 1 over 4. So I will move 1 unit up and then 4 units to the right. So 1.5, I end up at half, and then I move 4 units to the right. So 1, 2, 3, 4. So somewhere here. And this is 4. So I take my ruler, then I connect these 2 points like that. And then this point here where the 2 lines meet is what you are looking for. And if you've drawn it correctly, you should be able to see that this point is negative 2, comma, negative 2. And you can always check your solutions, see if they satisfy both equations. So if they satisfy only one, then check the way that you have drawn the graphs. They should satisfy both equations. Okay, do we have any questions on how to draw a line and how to use this method of drawing a line to solve simultaneous equations? Or are we fine? Are you guys still there? Or have I gone offline again? Hello? Can you guys hear me?
Miss,
Yeah.
can you please do an exam there?
Of what?
Uh, Using this method,
To do what?
way to draw the line cut.
Again. Okay. So what I said is if you have, let's make up, you have y. Let's say I have y is equal to 2 over 3 x minus 2. I want to draw this line here. What I will do is I will draw my x and y axis, this x and y axis. Then this point here is the y-intercept, so I'll plot that. So negative 2 is somewhere here. Then I will move away from this point depending on my gradient. So delta y, this is equal to 2, and delta x, this is equal to 3. So delta y means up or down. Delta x means left or right. So what I do is I start here at negative 2, then I move 2 units up, so negative 1, now I'm at 0. Then from 0 at the origin, I move 3 units, that means to the right. So I go 1, 2, 3. This is where I stop. This point here will be 3 because I started at 0 and then I moved 3 units. Okay, then I take my ruler and then I just connect the 2 points like that. And this is the line y is equal to 2 over 3x minus 2. So here I have moved 2 units because that is what my numerator is. And this side I have moved 3 units because that is what my denominator delta x is. Now with this previous one, what I did is I just drew 2 lines on the same graph using the same method. So this line had its own gradient, this one had its own gradient. I just draw both of them and then I look for the point where they meet.
Now we are together, miss.
Okay. Any other questions? Okay, if not, then we look at parallel lines. Now we say that two lines are parallel. I have line 1 and line 2. These two lines are parallel if the gradient of the first line is equal to the gradient of the second line. So two lines that have the same gradient, these are parallel. So for example, if I wanted to draw them, this is x, that is y. If I draw the first line, so I pick a point, then I move some units x, some unit y, then I connect the 2 points. So let's say I move 2 units and 3 units up. Then I have another line with the same gradient. Let's say the starting point is here. If I move 2 units and then 3 units, you will see that those two lines are parallel. So if I move 2 units and 3 units over there, and the gradient over here, this is 3 over 2, and this one is also 3 over 2. So lines are parallel if and only if they have the same gradient. So I can look at an example. We have these two lines. Y is equal to 3 over 2x plus half, and the line 2y is equal to 3x plus 3 over 2. So what you must first do is write both of them in standard form. So this one is already in standard form. It's already in standard form. It's just this one that you need to rewrite. So to do that, I divide by 2 on both sides. So I'll have y is equal to 3 over 2x plus 3 over 4. So the 3 over 2, I divide it by 2, I get 3 over 4. Then I look at the coefficients of x. The coefficient of x in the first one is 3 over 2, so m is 3 over 2. I'll call this one m1. And over here the coefficient is 3 over 2, so m2 is 3 over 2. These two are equal, it means they have the same gradient. So we say since m1 is equal to m2, the two lines are parallel. Parallel. Okay, and then when lines are perpendicular, see two lines are perpendicular. Now perpendicular just means they meet at an angle of 90 degrees. So they are perpendicular if when I multiply their gradients, the answer is equal to -1. Or you could say m1 is equal to -1 over m2. So the gradients are negative reciprocals of each other. So if we look at two lines, let's say I have y is equal to 3 over 2x plus 7, and then I have 3y. This is equal to 2x minus 6. So again, the first thing you should do is write them in standard form. This one here is already in standard form, so no need to change it. Then this second one, you need to rewrite it. So you divide by 3 throughout. So you have y is equal to 2 over 3 minus 2. So 6 divided by 3 is 2. So these are my two lines. This is line 1 and this is line 2. So your gradient of line 1 This is the coefficient of x. This is 3 over 2. Yeah, the gradient of 2, can put the x here, is just the coefficient of x, which is 2 over 3. So to check if these two lines are parallel, what you do is you multiply their gradients. So you say m1 times m2. So here I have 3 over 2 times 2 over 3. Here I'm multiplying 1. If the answer is not equal to negative 1, then it means they are not perpendicular. Okay, so I think we'll stop there for now. Do you have any questions on the straight line, how to draw it, how to tell if lines are perpendicular or parallel? Now remember, perpendicular and parallel, it's not one or the other. You can have lines that are not parallel, but they're also not perpendicular. And then you can also use this method to solve simultaneous equations. Do you have any questions? Or are we fine? Okay, if there are no questions, then I will see you guys tomorrow. So hopefully tomorrow we'll look at the parabola, how to draw a parabola, and then we should be done with the course. Then next week we can just do some revision. If you have any questions, you can post them on the group, and then we'll have a lesson where we go over all those questions. Okay?
Okay, miss.
Okay, miss.
All right, have a good day.